Okay, so today we are finishing 6.1, so we're continuing on. If you want, you can continue on your 6.1 notes from Friday, or you can start a new page. It doesn't matter. But this one does have a different title. We are going to be solving linear systems, this time using the substitution method. So that's why in the AO today, you were substituting as part of your AO. So we're starting with what we call the substitution method. So, here's the definition of the substitution method. It's a method for solving a system of equations. So, we're still working with systems, which is two or more equations. But this time, you are going to be substituting a variable in one equation with an equivalent expression. So, it's actually pretty much exactly what we were doing in the AO today. Okay? So, here are the steps to using the substitution method. So write down the steps, and then we're just doing a bunch of examples. So step 1, you are going to isolate one variable in one of the equations. So just one variable are you isolating in one of the equations, and sometimes this step will be done for you. So then you would go on to step 2, which is to substitute that variable with the equivalent expression in the other equation, so exactly what we did in the AO. Step 3, you will solve for the remaining variable, so exactly what we did in the AO. Step 4, after you have solved, so remember how in our AO today we plugged in the expression and then we solved for either x or y depending on what we were left with? Today, to finish the substitution method, you will have to substitute your answer back into the first equation, so that way you can solve for the second variable. And then you will have an x and a y. So step 5, you will write your answer as an ordered pair. Okay, so example 1, we have y equals 2x plus 2 and x equals 5. Those are our two equations. So the first step was to isolate one variable in one of the equations. I actually see that both variables are isolated. In the first equation, y is by itself, and in the second equation, x is by itself. Which one do you think we're going to plug in, though? X equals 5, right? So the second step is we're going to substitute in x equals 5 to the first equation. So here's what I would get. Y equals 2 times 5 plus 2. Now this one is easier because we already have one of the variables solved for. So my next step, guys, would be to do what? Solve, but multiply. 2 times 5 gives me 10. So that's y equals 10 plus 2. So y equals what? 12. Now, step 3 would be to solve for the remaining variable, which we did. Step 4 was to substitute our answer back in. So we would go to the second equation and plug in y equals 12. But is there any y to plug in? No. So we're done. So we write our answer as an ordered pair because this is 1 point on the line. This is the break-even point. Now we're finding the break-even point without having to graph. Okay, so remember how in the homework the break-even point was always like between 4 and 5 or between 10 and 11? Now you can find it exactly because we're solving algebraically. Okay, so this is a point. So on the point, what comes first, x's or y's? X. So it's going to be 5, comma 12 because y was 12. So you just found the break-even point without having to graph. Okay, does that make sense? So it's the same thing that we did on Friday, except this time we're solving algebraically instead of having to graph, which should be easier because we don't like graphing. So let's look at another one where we're only looking at expressions. So example 2. Okay, example 2. 3x plus y equals 15. And y equals 2x plus 5. This is actually really similar to what we did in the AO. Do I have a variable isolated already? No. Yeah, look at the second equation. I already have y equals, right? Isolated means you have x equals or y equals. That's what isolated means. So in the second equation, I already have y isolated because it's y equals. So what I want you guys to do is put parentheses around the 2x plus 5 and circle where y is in the first equation. So what we are going to do is we are going to plug in 2x plus 5 for y in the first equation. So it's going to give me 3x plus y, but we know that y is equal to what? 2x plus 5. So let's do plus in parentheses 2x plus 5 equals 15. Now I have plus a parentheses, so what do I need to do first? Yeah, finish the parentheses by distributing. But if I just distribute a positive 1, does that change anything? No. So just rewrite it as 3x plus 2x plus 5 equals 15. And guys, what would be my next step? Combine like terms. 3x plus 2x gives me what? 5x. So this is 5x plus 5 equals 15. I'm going to scooch it up now. What would you do next?
Divide.
I can't divide until I subtract 5. Remember, when you're solving, you do order of operations backwards. So you add and subtract first. So this gives me 5x equals 10, and then to solve for x, then you divide by 5. So you get x equals what? 2. Now, a coordinate is always x comma y, and I just have x equals 2. Does anybody have an idea of what we could do to get y? Plug it back in. So take that x equals 2, and I would suggest you plug it into the second equation. So I would draw an arrow next to it, because watch what happens. If I plug in x equals 2 to the second equation, that gives me y equals 2 times 2, right? Plus 5. So y equals 4 plus 5. So y equals what? 9. So write this as an ordered pair. What always comes first? X. So it's going to be 2 comma 9. Put it in parentheses and box it.